So, hello everybody, I'm back with another video, and yes, just as I promised you, this is going to be the sequel to my first video, which called where I played a little bit with the OPfC. And yeah, just as promised, I told you I would make a video where I will show you how to do it with a more layer system than just only a one layer system, and how to do it step by step. So let's get right into it. Now, as you can see here, I've already loaded up again a personal project. For those who weren't there in my first video, I'm gonna explain a little bit also here, but it is also quite, maybe there are some important facts. If you don't understand something, then you should maybe go back and watch the first video, because I explain a little bit more about the OPfC in general. And here is just, you already know the OPfC for those who watched my first video, and yeah, let's get into it. Now, here I've loaded a personal project again. So this time you will see here, you can open the personal project, and no, because we won't change anything. Now I've started off with the nano indentation of substrate, and yeah, we will calculate. So what I want to do now is, we have a more layer system, and materials are built like this. You have the substrate at the bottom, you have the, and maybe they can be built like it, but in our example we'll have an interlayer and we have a top layer. Now I won't change anything because I've already loaded up. So here's the OPfC, and we're gonna get right into it. So again, just in the first video, I've explained that you can change everything here. You also will need an own curve. Here it's just in the personal project, within the personal project. Now here you can see our substrate, and yeah, it's looking good. Now let's go ahead and start. So it's gonna jump over the E-fit, which is this thing right over here, because it doesn't need it for the substrate, it's just for the layers. So it's gonna jump right into calculate. Again, which I forgot, is this. I will just change it to get a better picture. So you don't have to change it at all, again, because the OPfC will calculate everything for you. Now let's calculate it, and as you can see here, it's really fast. And so also, no thank you. Now also, again, just as I told you, it calculated everything for you. So the max for me stress is for our substrate, only our substrate, because at the moment we are just looking at our substrate in this example, and we are not looking at anything else. So just the substrate without the layers, how it would look without the layers. And that's how we're gonna closely, as you maybe already saw and heard, I'm gonna closely take a look at at first we're gonna look only at the substrate, then we're gonna look at the interlayer, how it looks like if you just have the interlayer and the substrate, and then the top layer. So it's a step by step to know more about our material and the different layers and levels in our material. So yeah, we've done this. Now we're gonna go ahead and load another personal project. This time we will load the same project, but with our interlayer. So yeah, it's gonna bring us right here. And as you see, the curve now looks a little bit different. It's because of the interlayer. Now let's get into it and start the fit. So why do I do this with this software? Why do I use this software? It's because only this software can really calculate a E module and a max for mean stress. I'm pretty sure that no other software can do it. That's why this one is special, and I'm using this one to show you. And yeah, well, I just wanted to tell you. Now, of course, if you want to do this, if you want to change, if you want to put another layer on top of your substrate, so you have your data of your substrate, of your first layer, of your interlayer, and how many layers you have. So you have to do it manually by adding a new layer. Note that the first layer will be the one closest to the substrate, it will be the one furthest away from the substrate. So just if you have some problems, because I sometimes do, but yeah, let's get into it. Now this is how our first layer looks. Of course, all of these data you can change, but we're gonna keep them for this video. Now over here you can see I'm gonna start the calculation. I'm gonna speed it up a little bit so that you don't have to go through with everything. But just note that here you can speed up the calculation by having a higher accuracy, yes, and a slower speed calculation for really important stuff. Or you can just, for this video, it's fine if we do it really quick. Now we'll see us in a bit. So yeah, I'm back, and what did it do what did it actually do here? For those who don't know, here you can calculate the perfect Young's module, or how people like to call it also, the E module. Now that's basically it. Well, it calculates the best E module for our layer, for our first layer in that case. So okay, we are done, and it didn't take too long because I had fast calculation speed on and not high accuracy. But I think this will work out for the video. Now we're gonna calculate the max for mean stress for our substrate and for our first layer, because the max for mean stress changes of the substrate changes with, it has to calculate, but it changes, as you can see here. Earlier it was something like 19 gigapascals. Now it is only 200 megapascals. So it is a really big change if you have one layer on top of your substrate. So yeah, that's basically it for our interlayer. Now we're gonna go ahead and calculate everything with a second layer even on top, because again the max for mean stress will change, and we also want to know the perfect Young's module for our first layer, top layer. Again, I'm gonna do it with the personal project because it has all the data inside. You will have again to change it in the material, and you have to change your curve, of course. So let's go ahead and start the fit. Also, what I really like here, the software is pretty quick. So even with a high accuracy calculation, you can have a great speed. So yeah, as you can see here, this was our first layer earlier, and now this one is our first layer, our top layer, because obviously this is you also, what you could do to make it easier, you could all your data you could write down, and then you can just say we'll take this one out. But for this one we want to calculate now our top layer, because we've already done the other one. And now let's start our calculation. Again, I will shorten the time for you but yeah, we'll see us in a bit. So yeah, I'm back again, and yeah, we also did the same thing we did before, but this time for our top layer, which now is our top layer. Now, yeah, we've calculated the perfect E module fitting for our first layer, top layer. Now let's go ahead and calculate this. This might take a little bit longer because obviously the more data you have, the more time it will take. So the more layers, the more everything, the more precise you want it to be, of course, it will take longer, obviously. Now also, if you want a higher resolution, you can do this by changing these numbers over here, but I suggest to make them like somehow the same, because here it already did it itself. But yeah, enough talking, let's show you how it looks like. So yeah, it takes a bit, but it looks really good. Now you can really see the difference between no layers and one layer, two layers. And yeah, so this was basically it for the video. This just showed you how you can calculate, so how you look closer to your different layers in your in your material. I'm sorry, it's a little bit late for me. But yeah, this should be it for the video. Now, if you have any questions, I will make new videos, and if you have any, then write them down in the comments. So yeah, I hope you have a great day. Until next time, I see you. Bye bye.